Angular 19 introduces exciting new features. These features highlight the team's dedication and focus on signals. No doubt, signals are the future of Angular. In this video, we'll introduce the three new signal-related APIs: the linkedSignal, the resource, and the rxResource. These new features help shape the way we develop modern apps in Angular. We'll start with linkedSignal. linkedSignal is a new primitive that seamlessly blends the capabilities of computed signals with writable signals. It lets you build state that automatically updates while still allowing you to manually override it. This is a modern and flexible approach to state management. Next, we'll dive into the resource API. The resource API simplifies handling asynchronous data. It ties together promises and signals. It manages common states like loading, success, and errors. Most importantly, it's perfect for tackling race conditions in promise-based workflows. Finally, we'll explore rxResource. This new API ties together RxJS observables with signals and simplifies reactive data fetching in Angular. By the end of this video, you'll have a clear understanding of how these new features work and how to start applying them in your own project. So let's jump right in and see them in action. By the way, if you're interested in diving deeper into these topics, I've updated my Udemy course on all of these new signal-related features of Angular 19. Signals are now a key part of modern Angular development. Understanding them in depth is important, and the course offers a clear and comprehensive way to do that. I've included a link to the course and a discount coupon on the video description. Now, let's jump to all the demos. When you use signals and you want to create new ones, you have two primitive options to choose from. You can either use the signal function or the computed function. The signal function creates a writable signal, so you can modify it manually using set and update methods. The computed function, on the other hand, creates a read-only signal, and the value of this signal is calculated automatically from other signals. So it is derived from values of other signals. Now, in most scenarios, it's pretty clear which one you should choose. If your value is a core value, if it is modifiable by the user, then it is probably a writable signal. On the other hand, if it's derived from other values, then it's probably a computed value. But in some cases, it's not so clear which one you should choose. Consider, for example, this case, where we have a signal that holds a list of products, which is changeable, so you can add and remove products, and it holds a selected product, which is a single value from the list of products. So you can also change that. Okay, the user can change the next one or the previous one, and it's basically a writable signal because it's changeable by the user. So clearly we need, in both cases, writable signals. On the other hand, if they are writable signals without any relations between them, then you might get an inconsistent situation where you have a selected product that is not in the list anymore. So in this case, it's not so clear if we need to use computed or writable. On one hand, we want the user to be able to change it. On another hand, we want the selected signal to somehow be affected by the list of products. So for that case specifically, Angular 19 now introduces a new primitive called linkedSignal. linkedSignal, you might want to think about it as half writable, half computed. It's a combination of computed and writable signal. Now, when you create a new linkedSignal, you need to supply not a value, but a function that calculates the value. You need to supply an expression, and this expression relies on other signals. Now, just like computed signals, whenever the expression changes, the value of the signal will be equal to the latest value of the computation. But after the value, the expression has changed, you can continue to manually modify the selected product using set and update methods, because it is also a writable signal. So your latest value depends on whether it has changed manually using the set and update methods, or it was automatically calculated from the expression whenever it has changed. Now, if we do that, that means that the user can still select values. Let's save and refresh the application. The user can still add products and select values, but now every time it adds a new product, the list is refreshed and the expression is evaluated, which returns you to the original value, to the zero element. Now, sometimes you want the expression to also combine not just the computed other signals, but to also take into consideration the previous value of this signal. For example, in our case, we only want to automatically select item number 0 if the currently selected value is no longer in the list. So we want to take into consideration the previous value as well, not just the signals that we rely on. In that case, we have an alternative signature. Now, in order to make TypeScript as helpful as possible, it is best to tell the linked signals two types. One type is the type of the source signal that you rely on. In our case, it's a string array. So that means we create a linked signal that is linked to a string array, but the value of this specific signal is string. And now we supply it not with an expression, but actually with a configuration object, which contains at least two mandatory properties. The first one is the source, and in that case, it's the products. The second property is the computation function. Now, the computation function can take only the value that we rely on as parameter, or it can take two parameters. One is the latest values, and the other one is the previous value. And now we can decide what to return as a combination of the latest value of products with the previous value of the selected product. Now, because this function can be executed at least once before we even get an initial value, there is always the first time. Previous contains either an undefined or an object containing the previous source and the value. So we can not just use the previous value of our own signal, but also the previous value of the source. But in our case, we don't need that. So we're going to do the following. So if the previous is undefined, then we will simply return product 0, because this is the first time we compute. So obviously we need the first item in the list. Now, if the list of products includes the previous value, then we can just return the previous value and maintain it. Otherwise, if now the previous value is not in the list, then we return products number 0. And now what we have is an ability to select a value, change the list, but still maintain the value. But then when we remove the selected item from the list, it resets to the initial value, to item number 0. So that means that our linked signal, which is now a combination of computed value and a writable value, now behaves properly. And this is what linked signal is for. In Angular, signals are synchronous by design, but HTTP APIs are asynchronous. To bridge this gap, Angular introduces two powerful new APIs, resource and rxResource. The resource API lets you handle promises seamlessly using signals, while rxResource allows you to work with observables in a signal-friendly way. These tools make it easier to manage asynchronous data in your applications while keeping the simplicity and reactivity of signals. Angular 19 just made working with asynchronous data smarter and more efficient. So let's look at an example to see the APIs in action. Imagine we have a huge list of named colors and a service that allows us to search through them. Now, the service is implemented in two different ways. First, we have the search method, which is a little bit similar to the fetch API. It returns a promise and it supports abort signals, so you can cancel ongoing operations when needed. The second, rxSearch method, mirrors Angular's HTTP client. It returns a cold observable that emits a single value and supports cancellation by unsubscribing. So these two APIs will demonstrate how the resource and rxResource work with various different implementations of HTTP communication. But of course, you can use it also to any API that supports either the observable object or the promise object. So both asynchronous methods are supported with the new Angular Signal APIs. We also have a UI that is ready for action. So we have an input that automatically writes to a writable signal whenever it changes. And we also have the ability to present the results by looping over the results array and displaying the values. And we even have a busy indicator, which right now we always show, but of course in the future we would like to show it only when the search is in progress. So first, let's see how to use the resource API. Instead of displaying a constant value here, what we're going to do is we're going to create a new signal using the resource function. Now, it's important to mention that the resource function does not return a single signal. It actually returns an object containing various signals, and we'll see why. Now, the resource function receives an object with at least two mandatory properties. The first mandatory property is the request property. Now, the request property is an expression that will be used as effect, as a trigger. Every time this signal, this expression changes, it triggers the asynchronous work in the background. So we will provide it with an expression, with a function that is evaluated to some value that can change. In our case, it is the keyword. So this is the expression that triggers the search. Every time we change the keyword, we want the search to begin. And we now need to supply the second part of the resource, which is the loader. The loader is a function that returns a promise. And this function depends on an object that supplies it with information. So it receives an object and it needs to return a promise. Now we can use the search service to search for something, and notice that we need to supply at least a keyword. So where is the keyword inside the object? Well, if we search the content of this object, we'll see that it has three properties. It has a request property, which in our case is of type string. This is the value of the trigger. We also have the previous, and as you can see, it's an object that contains a status, and we'll talk about it a little bit later. And it has an abort signal, which returns an abort signal, which is an event that notifies you every time the previous search is canceled. Now, our search function can receive both, so we're going to pass the request and the abort signal. Now, what you will see is that we need to slightly change the template, because now the results is no longer an array of string. It's an object that contains a few things. It contains a few signals. One of them is the value signal. Now this is a value, this is a signal that holds at any point in time, it holds the latest result. If we'll save the file, we will now see that when we start searching, for example, let's look for the word blue, and we can see that we receive after 3 seconds all the colors that contain the word blue. Notice though that we don't just search for the word blue. In every keystroke, we begin a new search. So that means that we started to search for B, and then we started to search for BL, but notice that it was also aborted. And the reason for that is that the abort signal signaled to our search method that it needs to cancel the promise that it has created. And because the search function takes an abort signal and subscribes to it, whenever a notification arrives, it cancels the timeout, or in any way it cancels the operation. Now, several asynchronous operations know how to cancel themselves, so they can work with abort signal. Fetch is one such API. So we see that only the word blue actually returned a value. It completed successfully. It was not aborted. In that sense, the resource API behaves a little bit like switchmap from rxJS. It cancels searches that are in progress if you start a new search. So this is the resource API. Now, there are a few interesting things to see here. One of them, for example, is that you can get an isLoading property from it, which you can use to decide if you want to show the please wait or the progress sign. So we can rely on results dot isLoading, and notice that this is also a signal, so it still complies with the reactivity paradigm that Angular supports from version 16 and on. So now, when we look for one of the colors, for example, when we look for magenta, you see that it continues to be true until the most relevant search is completed, and then it turns to false, and the progress indicator is then gone. Now, 2 quick words about resource. First of all, resource is a linked signal in the sense that it combined computation with writable signal. So it is a writable signal. You can actually change it. For example, by clicking the reset resource, you see that we reset it to a local value. And just like linked signal are writables, the resource signals are also writable. Another thing to see here is that the resource API returns an object that also contains a status signal. And the status signal can be used to see what is the status of the resource. So now, for example, we can go to the constructor. And in the constructor, we can add an effect that will print out the current status of the results resource. So log results status. Now, again, this is a signal. This is why we want to print it inside an effect. And as you can see, we get numbers here. We get the number 2, then we get the number 4. If we click the button, it changes to number 5. If we start a search again, it then changes to 2 and then again to 4. So what is the meaning of the number? If we'll press F12 here and then again F12 on the type of signal, we see that this is an enumeration that contains a few values. Idle means that it never had a value. This is what you get when your request is undefined. Error is when your promise returns an error, and in that case you also have an error signal which returns the latest error. Loading is when we're busy with running the promise, when the promise is in progress. Reloading is when you manually call the reload method. A resource contains a reload method which you can use to initiate reloading But in that case, when you reload, what you actually do is you trigger the same promise with the same value of request that you used before. So it reruns the promise with the latest value. And in that case, your status changes to reload. Resolved is when the promise completes successfully. Local is when you give the resource a local value, when you change it using the set or update methods, and you basically give it a value without using the promise. So in that case, it is local. So as you can see, resource try to give you a good and simple solution for quite a lot of different use cases when working with asynchronous values. It's not all the cases, but it's quite a lot of them. It's definitely the 80%, if not more, of the scenarios when working with asynchronous APIs. Now, rxResource is pretty much the same idea, except it works with observables instead of promises. Now, in our case, the search service provides the same functionality through an rx search method, which, as I said before, resembles the way HTTP works. So what you can do is, instead of using the search, the resource function, you can use the rxResource function. And then, instead of supplying a method that returns a promise, you will call a method that returns an observable. And in that case, you don't need the abort signal because the observable itself is cancelable. So by unsubscribing from the observable, the search is aborted. And as you can see, apart from these two very slight differences, it returns exactly the same results. And you can even see that searches were completed, basically aborted, because we started a new search, but the latest search, the one that we did not interrupt, actually returned a value. So this is pretty much the same idea, pretty much the same API, except it works with observables instead of promises. All right, so that's all there is to it. You're now ready to get going with the new Angular 19 signal-related features. I hope you enjoyed the video, and please come back to my channel for more videos on Angular.